This brings us to Newton's second law of motion, which is more famous among scientists, but less famous among everyday folk because of it's basically a math equation. So Newton's second law is basically an equation that says force is equal to mass times acceleration. This is kind of like the famous way to say it, but I think the more useful way to describe it is that acceleration is directly proportional to force and inversely proportional to mass. In other words, more force gives you more acceleration, more mass gives you less acceleration because the mass is resisting acceleration. So let's go over the three main ideas here with this second law. Acceleration comes from unbalanced forces, and that's part of Newton's first law as well, but it makes sense here, right? If you look at the equation, if the force is 0, then the acceleration would be 0, right? So you're only going to get acceleration if you have an unbalanced force, a force that's not 0. Then you've got a larger force makes a larger acceleration. Larger force, larger acceleration. And again, back to this arrow right here. If that force number goes up, the acceleration number will go up. That's directly proportional. And the last thing is that acceleration is inversely proportional to mass, right? Since mass is on the bottom of this fraction, the bigger the mass, the smaller the acceleration. And all three of these ideas, aside from making sense within the equation, I think they make sense if you just think about it logically, right? How do you get something to accelerate? You apply an unbalanced force. How do you make it accelerate more? You push harder. What if its mass increases? Well, then it's not going to accelerate as much because it's harder to push. So here's some illustrations that show that. You've got from 1 to 2, right? These two right here. You're increasing the force, right? So a little bit of force, bigger force. More acceleration. For 3 and 4, these two right here, you're increasing the mass. More mass gives you less acceleration. So let's take another break to do a concept check. Why does a tractor-trailer have a bigger engine than a car? Again, the tractor-trailer has more mass, so it needs a bigger engine to create a force that can accelerate it the same way a car accelerates. Second one, why would a truck driver want to leave more space between the car in front of it than a normal car? And that's because it's going to take a greater force or the same force over a longer time to stop that truck. So basically it's harder to stop a truck, it's got more inertia, and so it wants to leave extra space. Let's take a look at two graphs and look at how the net force is shown. So remember, net force, if it's 0, there is no acceleration, right? So that's here, right? 0 acceleration, right? It's a flat line, which means the net force is 0. Whereas this one is slowing down, right? Its velocity is decreasing. So this has a net force not equal to 0, something that's causing it to slow down.